right, slurp camera. How's my bad haircut? I wish I could see Rocco. All right, I'm Phil McCaffrey. Welcome to 8:30 Prep. We are live streaming some test prep. As always, I'm focusing on the ACT because it is the much more stable test. I'm going to start a new blog because I got and I wrote my first article for it today. I got an email from Dr. Dave at North Hills High School, and he said, could you summarize the difference between the ACT and the SAT? And my summary is the ACT is like your plump aunt from Iowa who serves pork chops, and she's very stable. She's just a really nice person. And the SAT is like my cousin Vinny. He's a tough guy from New York City, and I call the SAT the schizophrenic toddler. So the SAT hasn't figured out what it wants to be. What it really wants to do is replace your state testing. So anyways, this week is my geometry week. I'm playing out all the geometry on a worksheet I made off of old ACTs. So some of these may or may not be perfectly legal to display on the internet. So if the ACT's watching, they're going to shut me down. But I seriously doubt they're watching.
We just don't mention that.
Yeah, we don't mention it.
As
long as we don't say that this is illegal. Hey, Jay Hadfield. All right, thanks for tuning in, Jay. So my stepson, Jay Hadfield, out in Oregon. And just stay tuned, Jay, for a second because I got a meme for you. Say hello to Teo.
Hello.
Teo is the other stepson and producer of 8:30 Prep and working on some of my memes. So today we're going to do quadrilaterals and a little bit of polygons on the SAT and ACT. The SAT has dropped geometry like a brick. Nobody likes geometry. I wanted to teach a real quick lesson, and that is on what a word that they like to use a lot, which is regular. And a regular polygon means that they're equilateral and equiangular. So if I have an equilateral triangle, it has 3 sides and 180 degrees. And 180 degrees divided by 3 means that each angle is 60 degrees. A regular quadrilateral is a square and it has 4 sides. It is 360 degrees and each angle is a right angle that's 90 degrees. So this is the total, and then this is an individual angle. A pentagon has 5 sides, and it has 540 degrees with an individual angle of 540 divided by 8, or 108 degrees. And a hexagon has 6 sides, or 720 degrees divided by 6 is 120. So this is 120 degrees. It's worth pointing out that the hexagon is made up of 6 equilateral triangles. So they like to play around with equilateral triangles. If you watched yesterday, there was one thing that I didn't point out, maybe that an equilateral triangle split in half is a 30, 60, 90. The formula for this is the famous n minus 2, where n is the number of sides, times 180 degrees. So that's 3 minus 2 would be 1 times 180 degrees. And then the formula for the individual angle of a regular polygon is n minus 2 times 180 divided by the number of sides, n. So let's jump right into it. Quadrilaterals are always 100% on the ACT. And here's the throw out to Jay. Here's a pentagon, a hexagon, an octagon, and an Oregon. So Jay, that's why I wanted you to watch. So you can stop now. Come on, make a comment. All right. So he can't see. Oh, he can't see it yet. That's right. It's 20-second delay. When you're filming, we're not filming. When you're streaming live on YouTube, there's a 20-second delay. So here's an easy one. We're going to go from easy to hard on octagons, on polygons and quadrilaterals. Belinda plans to use landscaping timbers to build a border for her 8 by 12 foot rectangular garden. She must determine the number of timbers she needs. How about if I speak English? Slurp break, slurp camera. slurp camera. She needs the perimeter. So what we can do is, I love me a good smartboard because it does things like this. All right, it gives me just great, awesome 8 by 12. What is the perimeter? There's a 12 down here and an 8 over there. You all know that's how rectangles work. And so this is 24 plus 16, which ends in 0. 40. Last digit math like yesterday. Love doing it. The perimeter of a square is 24 feet. What is the area of the square in square feet? A square, interestingly enough, if you all don't remember this, a square has an area of the side times the side, or the side raised to the exponent 2. We say the exponent 2 is a square, because before we ever had the exponent 2, we had the area of a square. So we still use that. And the area of a cube, or excuse me, the volume of a cube, is a side times a side cubed. So the exponent 3 is a cube. Anyways, so this is 24 feet. There are 4 sides to it. 24 divided by 4 is 6. What is the area of the square, which is 6 squared, and 36? As you can see, there are very easy problems with quadrilateral. There's always a nice, easy square or rectangle. Number 17, still in the relatively easy phase of the ACT. What is the length in feet of the side of a square whose area in square feet is equal to the area of a 25 by 16? Let's toss in a square. Phil's rules, always read with your pencil. The side of the square whose area is equal to the area of a 25 by 16 foot rectangle. So let's just call this a rectangle, and it's 25 by 16. I like to play games with the numbers on the ACT. 16 is 4 times 4, and 25 is 5 times 5. So if this square had the same area, its area would be a 4 times a 5. So what is the length in feet of the side of a square whose area is equal to 25 by 16? And that's 20. So that is the length in feet of the side of the square, 20. Now I like to point out sometimes how they come up with the tricks. And one of the tricks is 25 times 16 equals 400. So notice that 400 is one of the answer choices. You can make a mistake halfway through by doing 25 by 16, but then you have to take the square root of 400, which is 20. All right. This is a famous ACT problem, and that is they have used it over and over and over again for the years. I don't know if they're going to repeat it again, but I do like to show that it is repeated, and that is the perimeter of a parallelogram is 76 inches, and one side measures 14 inches. If it can be determined, what are the lengths in inches of the other 3 sides? I'd like to point out that this is a number 30, so the answer choice K almost always is wrong. From 30 and above, it can be determined. The answer choice K cannot be determined is only on easy questions. I hate to say this, but a weak student cannot determine an answer, and a strong student can. So once we get past the middle and we're on to the harder of the mediums, or a hard question in the 40s or 50s, if it's in the 40s or 50, K is always wrong. I have never ever seen it be right, because a weak student could just say, meh, I don't know, and it can't be determined, where a strong student will determine it. So it's a parallelogram, so it has to have another side of 14. Notice 14 is an answer in all of these other questions, in all the answers. It can't have 3 sides of a 14 if it can be determined what are the lengths of the other 3 sides. So it has to be 14 and something else. So what do? We take 76 minus 2 times 14. So let's take our handy-dandy TI-84 that somebody left in my office. Whoever you are, if you're watching, this is your calculator. 76 minus 2 times 14 is 48, and half of 48 is 24. So the sides are 14, 14, 24, and 24, which add up to 76. Look, here's the exact same question. This was a number 30. This is a number 35. It is exactly the same with only one number changed. I wanted to show this to you because I showed it yesterday, that the ACT over the years has taken the exact same question, the exact same wording, and just changed the numbers, like a good math teacher does. So it's worth practicing. What do you practice? You practice what is called the Test Information Release, the TIRs. And where can you find them? On Reddit. Let's look at a number 41. The area of a rectangular garden in a city park is 162 square yards. The length of the garden is twice its width. What is its perimeter? Let's toss out a rectangle. And then let's write in what we've got. So we have the width, and the length is twice. So read with your pencil. So we got 162 square yards. That's my area. And the length is twice the width. So down here I have two widths and another widths. One of the things I like to do is play around with an ACT test. And if I take 162 and divide it by this total, 2 and 2 is 4 and 5 is 6, 162 divided by 6, let's see what that is. It's 27, which is wrong, because the area is 162. So the area is length times width, W times 2W equals 162. This would be 2W squared. Divide by 2, I get W squared equals 81. So the width is 9. It wants to know the perimeter. 9 times 9 plus 9, 2 times 9 is 18, and 18. So we've got 2 times 18 plus 2 times 9. And that's going to equal 54, which is our correct answer. Excellent. Fun question. I love to see how they come up with these wrong answers. I wish I could spend more time doing that and figuring out. I'm just not evil enough to come up with the wrong answers. Here we go, a number 38. So we're getting to the hard, and this is hard because it's 2 steps, and it asks the area of a trapezoid. It says a contractor charges $1.75 per foot per square foot to waterproof the top surface of a wooden deck. What would be the contractor's charge for waterproofing the top surface of a trapezoid-shaped wooden deck shown below? The top is 14, the bottom is 24. And the area of a trapezoid is base 1 plus base 2 divided by 2 times the height. So this is base 2, this is base 1, this is the height. So our formula is we could enter the whole thing in, and that is going to be $1.75 per square foot times the quantity, parentheses, quantity, 14 plus 24, quantity divided by 2 times 10, quantity. I can enter this whole thing straight in to the TI-84 and get out $332.50. I did actually practice that one, Teo. Since I screwed up yesterday, I did practice it. What is it? It is the area here times $1.75. Now the question. Trapezoid, KLM, shown below. The measure of angle M is 45 degrees, and K and N are both right angles. The given side lengths are in feet. Which of the following values is closest to the area? We have a 45 degrees. Folks, this is not a quadrilateral question. It is a trapezoid question that is really a triangle question. And as I like to say, if it looks like a triangle, it is a triangle. Since this is 45 degrees, we have to find the side lengths of an isosceles right triangle. This is going back to yesterday. We know that the hypotenuse is side times the square root of 2, and that's equal to 10. So this is base is 18. We want to know which of the following values is closest to the area, and square foot of KLM. So I need to get this height. So let's take 10 and divide it by the square root of 2. And that equals 7.07. So this is going to be 7 times 7. So 18 plus 18 plus 7, 25. 18 plus 25 divided by 2 equals 21.5 times 7. 150.5 is what I came up with. So I didn't do this all the way out, and I could have, but the answer is E, 152. Remember, the area of a trapezoid is the average of the bases times the heights. And I could have typed this whole thing into the calculator and gotten closer to it, but when it's 7.07, just use 7. You will get the closest answer. All right, a 55. I saved this one without doing it because I actually want to do this one live. What is the area in square meters of a rhombus? A parallelogram having 4 congruent sides, with side lengths of 4 meters and 2 angles that each measure 6. All right, I practiced drawing it, so let's see if I can draw me out a rhombus. How's this looking? Is this looking pretty good? Not bad. Close enough. I'm not that good at drawing. All right, so this is a rhombus, and it has 4 congruent sides, length of 4 meters, and a degree of 60 degrees. Once again, this is not a question that is a quadrilateral question. It's a triangle question, because this is 60 degrees. So here is 60 degrees. So the angle is 30, 60, 90. I think I drew this off. I think that's a little too far. So what do I have to do? The hypotenuse of a 30, 60, 90 is twice the length of the opposite side. So this is 2. Yeah, this is completely off, because this is also then going to be 2. So it's 2, 2, and 2. So this height is 2, and this base is 2. The height times the base is 2 times, this is 2 times the square root of 3. Right, so this is 2, and this is 2 times the square root of 3. So what I was going to guess, so 2 and 2, the base is 4. When it said 60 degrees, the one thing about a 60 degrees is we have 30, 60, 90, x, 2x, x times the square root of 3. The one thing you can do if you don't know what to do, and there's a 60 degree angle in it, is guess square root of 3. So I'm going to guess 8 times the square root of 3, because 16 times root 3 is too much. This, if this was a square, it would be 16. So it is 4 times 4 is 16 is too big. And the right answer is actually the base times the height, which is 4 times 2 root 3, which gives me 8 times the square root of 3. Fun problem. I'm glad I got it right. Haven't screwed one up yet today. Okay, from the official practice test, we only have 2 polygons, and I haven't had any angles, so I didn't look too hard for polygon questions. This says Min cuts a board in the shape of a regular hexagon. Regular, of course, has nothing to do with anything here, but it means that the angles and the lengths are the side. She pounds nails in each equal distance from the vertex as shown in the figure below. How many rubber bands will she need in order to stretch a different rubber band across every possible pair of nails? This has nothing to do with the hexagon. It's a counting problem. And I'm going to count nice and fun. 1 rubber band, 2, 3, 4, 5, 6. And I'm going to do it in a way that you can't do it on the ACT, which is I'm going to do it in color. 7, 8, 9. This is 3, so it's going to go total of 9. 10, 11, 12. 3 more, that's 12. And which one am I missing? This side, 13. So I need 3 from each side, 13, 14, 15. The answer is 15. There's a formula for this. I wouldn't memorize the formula for this, but that's how you do that is how you do a counting problem, is draw it out. Yes, I can speak English. Here is another official practice test with a hexagon. What is the maximum number of distinct diagonals? I wanted to use this one for that word, a diagonal. A diagonal of a polygon is between the vertexes, but not the edges, that can be drawn in the hexagon below. Actually, a diagonal of a square has 2 diagonals. That's a diagonal, and that's a diagonal. The only polygon that does not have a diagonal is a triangle. So let's count the number of diagonals. 1, 2, 3, 4, 5, 6, 7, 8, and there's got to be 3 from each one, 9. 7, 8, 9. We knew that there was 15 from the question before, and I subtract 6 sides, I get 9. The answer is 9. I'm Phil McCaffrey. This is 8:30 Prep. Please send me some memes. Your mom's on Teo saying hello to Jay. Thanks for watching, Jay. I'm sure you're probably not watching anymore now. But 8:30 Prep, during the quarantine, every Monday through Thursday at 8:30 live on YouTube. My website is 3rprep.com. If you want some practice questions, please email me at phil@3rprep.com. And I'm starting to get lonely without new students, so come down and see me on Zoom. We'll start doing some classes. No shout out from Gavin tonight. Gavin, are you there? Oh, well, he was there yesterday with his cousin Alex. So I'm Phil McCaffrey. I'll see you tomorrow night for what's tomorrow? Circles. Wednesday night will be circles. Not bad. 8:52. We'll see you tomorrow night.